The Bahrain World Trade Center's greatest legacy will be symbolic.
The most important message that the building has is that it is looking...
Bahrain's capital, Al Manama, sits at the edge of the Persian Gulf. Each morning as the sun heats the island of Bahrain, hot air rises. This creates an area of low pressure which draws cooler air in from the sea. This daily cycle produces strong onshore challenges. Turbine blades capture the energy of moving air, sending it to a generator which converts it to electricity. But to be able to rotate, the blades need uninterrupted winds coming directly at them. For this reason, wind turbines are mounted on vertical poles and can turn to face winds from different directions. Keyless turbines, however, would be on a horizontal axis, fixed in position, unable to turn into the changing winds. The second major challenge is the way Keeler wants to stack the turbines. Because wind speed increases with height, the higher turbine will spin faster and create more power than the lower turbine. All three turbines need to rotate at the same speed, or the top one will wear out sooner. Keeler realizes the key to making the turbines work is the shape of the towers. Again, the architect's experience as a sailor provides the inspiration for the solution. The towers resemble two tall sails. In plan, they have an elliptical shape like an aeroplane wing. To compensate for the turbine's inability to turn, Keeler hopes the shape and orientation of the towers will funnel the wind directly into the turbine's path. The tapering shape of the towers also means they will funnel more wind to the lower turbine and less wind to the higher one, making all three rotate at roughly the same speed, yielding approximately the same amount of power. The blades will turn up to 38 times per minute, creating a huge moving force on the bridge. For this reason, the engineers discover that the marriage of the turbine to the bridge could create a disaster scenario, a phenomenon known as resonance. The wind will rotate the blades, but it will also cause the bridge to vibrate up and down. If the vibrations of bridge and turbine are ever the same, they will begin to amplify each other, increasing and intensifying until finally the bridge can no longer bear the force. To avoid this catastrophe, the engineers decide to make the bridge design more rigid. This will actually make the bridge vibrate faster than the turbine, eliminating the risk of resonance. But wind tunnel tests reveal another potentially deadly hazard. If the wind changes direction or gusts suddenly, the blades of the turbine could deflect and strike the bridge. A normal wind turbine on a vertical axis is tilted back 5 degrees to avoid the possibility of the blade striking the pole. But that's not an option on the bridge. Each blade is capable of deflecting more than a meter back. To avoid blade strike, the sides of the bridge's front edge are drawn back, creating a slight V shape. The modification creates a distance of 1.7 meters between bridge and blades, enough to avoid a disastrous strike. Trade Center's greatest legacy will be symbolic.
The most important message that the building has is that it is looking